In this video, I would like to give you some guidelines for selecting brushed or brushless DC motors. At Maxon, brushless DC motors are called EC motors. For finding the right motor size and winding, please refer to separate videos. The most important difference between brushed and brushless motors is service life. Brushed motors suffer from a limited service life of the brushes. Usually you can achieve a few thousand hours, in best cases up to 10,000, in worst cases less than 100. Brush life is difficult to predict and there is no secure way to calculate it. A lot depends on the use. High current, high speed, left-right operation and a high vibration reduce life. All you can do is make some guessing by comparison to similar applications and operating conditions. A few thousand hours of service life are sufficient for many applications. However, some applications with constant operation need several 10,000 hours and the use of brushes should be avoided. In brushless motors, the expected life of the ball bearing essentially limits the service life. Ball bearing life is much better understood than brush life and can be estimated quite accurately. Typically, they are made for several 10,000 hours. But still, there are many applications that don't need the high service life of a brushless motor. What are the differences between brushed and brushless motors concerning speed and torque? As a starting point, let's take a brushed DC motors of a given size. Typically, maximum speeds of DC motors can go as high as 20,000 RPM, but in most cases they are limited to values below 10,000 RPM. At higher speeds, service life is strongly reduced due to increased electrical and mechanical wear. A brushless EC motor of similar size and magnetic design can be operated at much higher speeds, reaching 100,000 RPM in some cases. These are perfect motors for applications running at high speeds, such as grinders, cutters, and some blowers. It's interesting to note, however, that brushless motors are often made multipole. This enhances the torque, however, at the cost of speed. In many applications, extremely high speed is not needed, but more torque would be nice to have. But clearly speaking, one of the main advantages of brushless DC motors is that they can reach higher speeds. Please note that these are only trends. You will have to look at the specific datasheet of each motor to get the information about maximum speed and torque capabilities. Brushed motors can cause complications in special ambient conditions. Brush fire is at the origin of electromagnetic noise, which might require additional damping. In explosive gas ambient, the sparks might also not be too welcome. However, note that a brushless motor is not explosion-proof on its own without further modification. Graphite brushes produce graphite dust that might pollute clean rooms or high vacuums or optical devices. Graphite brushes need some humidity, but not too much, and oxygen in the atmosphere to work properly. Precious metal brushes are lubricated. As a result, both brush types show limited suitability for the use in vacuum applications. Therefore, most motors for special ambient conditions are brushless. Think of motors that can be sterilized, or motor for ultra-high vacuum applications that need previous heating, or motor for space applications, or motor for downhole drilling that have to support high levels of vibration and temperature. When it's about motor operation, there's no other motor as simple to operate as a brushed DC motor. All you need is applying a voltage and the motor turns. For operating a brushless DC motor, an additional piece of electronic is needed for the commutation. Cabling is more complex. There are up to 8 connections to be made just for running the motor, compared to the 2 connections for a brushed motor. The situation changes, however, in applications with higher levels of control. Usually, controllers for motor speed, position or torque can be used with both type of motors, brushed or brushless. In such cases, the additional costs for the electronics, feedback and the additional cabling effort are very similar. Brushed DC or brushless EC? In the end, it's a choice you have to make for your application based on speed, with high speed advantages for brushless motors, service life, ambient conditions, where adaptation usually is easier on the brushless side as well, and complexity of operation and cabling, with advantages on the brushed motors for simple operation. That's it, a short comparison of brushed and brushless DC motors. Keep in mind, look at all aspects of your application. The choice between brushed and brushless is dictated by technical consideration as well as environmental conditions and service life, and, in the end, commercial aspects.